Now we're going. Yeah. And before we get started, we just have a few housekeeping items to get through. Let's see. Um, so first of all, formally welcome everyone for joining today to go over the introduction to LaTeX, which it sounds like everyone has some familiarity with, but I think no matter what your skill level, this is going to be really helpful. So we're looking forward to it. So just a few things. If you would like any other sessions or webinars like this that are more technical in nature, or any kind of discussions you'd like to have, please let us know. There's a few ways you can do this. You can email nnip@urban.org. You can email Kathy or I at our urban emails, or feel free to post ideas to the forum. That's always a good way to get discussions going. And if you're interested in more of these technical discussions, you can also join the Technical Affinity Group, which is one of the groups that we have on the platform. There you can share projects you're working on, tasks you might need help with, ask questions, share resources, anything like that. So always welcome new members for that. And then just a quick plug that our next idea showcase is on July 9th, if you didn't see that announcement already. So if you have any ideas that you would like to present for that, or that you or have any staff more junior staff who you want to give a chance to present, please let us know. Same thing, you can email nnip@urban.org, but please do that by the end of this Friday to get those volunteers in. So again, today's webinar, big thanks to our presenter, Moshe Haspel. If people didn't see the description, it'll be in three parts today. The first will be going over the more introductory basic LaTeX concepts, and then I'll be doing a deeper dive into some of the more nuanced mechanics, and then finally going over the automation tool that he developed. So with that, Moshe, take it away.
All right. Well, thanks y'all for coming today. Give me 1 second here so I can switch over to my deck. Let's see. Oops. And share. Can everybody see my screen?
Yes.
Excellent. Okay. So before I get started, first thing that I want to just let everybody know is that everything from today, that includes this deck that we're looking at, all the code snippets we'll be looking at, this data do file that I have that makes tables, all of that will be available, not will be because that would be future tense. All of that is available via this repository. It's all up, ready to go. Um, and that is going to allow me to move quickly. So we're going to move pretty fast, because you'll be able to go back and look at slides and look at code and all that. I have a lot of slides, and in respect for your time, we're going to move pretty fast. Uh-oh. Slide didn't advance. There we go. Okay, and as Cole mentioned, there are sort of three units that we're going to have today. First one is basics, or what is LaTeX, how do I use it, and then I'll show a sample workflow for designing a data profile or data fact sheet. And for a lot of you, that'll be great. You'll say, "Hey, thanks for showing me this. This was cool." That is enough. For those of you who say, "Yeah, that actually this is something that we might actually implement," you'll want to stick around for Unit 2, which is going to be the deeper dive. We'll look at a little bit deeper at the structural things about how LaTeX works, which will help you when you are designing your own things. And if you are a true masochist, you can stick around for Unit 3, which is where I'll show a little bit about the The ADO file that I wrote, I call it LaTable. It basically helps you generate tables in your data fact sheets using Stata. Automate basically automate that. Um, so just to kind of get started, let me ask you a pop quiz. So let's say you author a book and you are disappointed with the quality of the typography in those galley proofs. Do you? A, suck it up and make do. B, find a different publisher. Or C, author a computerized typesetting system from scratch. If the answer is C, then we are in the presence of greatness. Donald Knuth, who won the Turing Award, that's effectively the Nobel Prize of Computer Science for his work on algorithms, has been working on this multi-volume book called The Art of Computer Programming literally for the last several decades. The first edition of it's multi-volume. Some of them are in print, some of them he's still working on. The first edition of one of his volumes was initially printed using hot metal typography, and then the later edition was reprinted using photo typesetting, and he was not happy with the result. If you have any books from like the mid 70s that have that like kind of blobby looking typesetting, that's the photo typesetting. And he wasn't too pleased. And as the son of a print shop owner himself, he had an appreciation for good typesetting. So Professor Knuth embarked on a side quest, and he developed three things. Tech, which is the markup system itself. Metafont, which is a system for specifying fonts to be used with tech. And he designed a typeface called Computer Modern. It's the default base font for text. So we'll actually be seeing some samples in a few minutes. This guy is really interesting. He's by some accounts considered to be the greatest living computer programmer. The New York Times has this nice article that called him the Yoda of Silicon Valley. Um, Dr. Knuth did a real deep dive into the typography. He paid a lot of attentions to things like kerning, that's the spacing and even overlap of individual characters, and ligatures, that's when two letters are sort of joined into a single glyph. His obsession with getting these details right is why his output looks so nice. The ligatures, if you look at the text there in the bottom, that is actually in his computer modern font. If you look at that word fluffernutter, you see how the F and the L are combined, how the two Fs are combined. You can see how the U and the T, how they're so close that they basically kind of overlap. And it looks nice. He did a great job. One problem, the text system, and by the way, uh, it's pronounced a hard K, or it can also be a H rather than a X type of sound. That's because it is Greek, but we'll talk about that in a minute. It wasn't particularly user-friendly. It was written by a guy who programmed a machine language and whose specialty was in writing compilers. So it took another computer scientist, a guy named Leslie Lamport, a Turing Award winner in his own right, to make the system we enjoy today. He was typesetting a book he had authored using tech, realized the macros he was writing for himself could make a more accessible typesetting system for everyone. And that's how LaTeX was born. The name is a portmanteau of Lamport and tech. Lamport also published the first LaTeX user manual, which was crucial to making the system a success. Lamport thought the book might sell a few hundred copies. To his shock, it sold hundreds of thousands. Oops, I'm sorry. Um, should have showed you his picture. Okay, so what is LaTeX? Um, so it is a free and open source system. It is a markup language, so kind of HTML. It's not doesn't have the same form as HTML, but like HTML, you've got text and then you've got stuff around it in order to tell the system what to do with that text. The system is extensible through packages. It's cross-platform. It doesn't care. You can use Linux, you can use Unix, you can use Mac, you can use PC. It doesn't matter. It also is designed to make device independent output. Nowadays, that's typically PDF, but there are some other device independent formats that it can generate. And it is well established and documented. And that last point is really important because it means you can get meaningful and usually, but not always, right help from Copilot, Gemini, Claude, or any of those kinds of systems when you get stuck. And you will get stuck. LaTeX is also a bit of a shibboleth to identify fellow nerds. If you see a CV or a resume that's set in LaTeX, it'll really stand out from ones that are generated, say, from, say, Microsoft Word. And of course, my favorite thing about LaTeX, you can use scripting to automate the creation of many documents, what we will be looking at in just a few minutes. Okay, now it's worth noting LaTeX isn't the only game in town. There are competitors. It's worth looking into these alternatives before investing your time in learning LaTeX. Um, Typist in particular is supposed to be a lot more user-friendly. It's less powerful, but it's more user-friendly. Um, the automation piece that I'm going to demonstrate later this unit could be adapted to any of these systems. Um, but we're going to plow forward using LaTeX today. So lovely. Now that you know what LaTeX is, how do we actually use it? Well, there are a few ways to get started. You can sign up for an online service like Overleaf. Overleaf, the basic account is free. It operates on a freemium model. If you're going to do your own work, you can use it pretty much for free. If you're going to collaborate with others, then you need the paid account. You can also install software on your local computer, which is what I do. I work offline. I use the cross-platform program MikTeX. Um, it is available for Windows, Mac, and Linux. Most Mac users I know actually prefer MacTeX. But it doesn't matter which one you use. Any of these setups will provide you with the same type of environment. It's an IDE type environment. So you code in one window, you get your messages in a console. Of course, you don't want the messages in the console because those are usually errors. Output comes out in a third as long as everything's running right. Um, and of course, because it's a markup language, you can code LaTeX in any text editor and then run a compiler to yield your final document. So it's very flexible how you're going to get moving with it. Now, the document itself consists of two parts, a LaTeX file. There's a preamble and then the document itself. The preamble is where you initialize the file. You need to tell LaTeX the class of the document to be created. Are you making a book? Are you making an article? Are you making slides? It matters. Um, then you can tell it any packages to load, any custom definitions like macros or colors. We'll see a lot of that. The document class is a required element in that preamble. Everything else that I mentioned is optional, packages, macros, all that. Then the document content lies between a begin document tag and an end document tag. Everything between those tags gets evaluated for typesetting. Anything located after that end document tag is ignored, so you can leave comments there if you like. You can also make comments within the document. You just preface the comment with a percent sign. Anything after percent sign on a line is going to be ignored by the compiler, unless, of course, you escape that percent sign. So if you want to show the actual percent sign in your document, you do a backslash and then the percent sign, right? If you've done any HTML, you understand about escaping characters. There are other special characters like the backslash itself, ampersand, dollar sign, curly braces that you also require some special treatment, usually escaping. And then all LaTeX commands follow the general form. You have a backslash, the name of the command. Inside square brackets, you would have any optional parameters, and then inside curly brackets, you would have any of the required parameters that a thing might require. Okay, that was boring. That's enough theory. Let's put this all into practice with a short demo. So here's a screenshot from TechWorks, which is the console system that comes with MikTeX. Note, you can see the different colors. It provides syntax highlighting, which can be helpful so you can make sure that your code is well formed. This is pretty much the simplest possible document you can have. We've got a one-line preamble, a begin document tag, one little nugget of text between the begin and end tags, and that's it. As a nod to every programming tutorial out there, we're just going to have that document say hello world. Now, in these systems, you typically get a choice of compilers. That's the compiler in MikTeX. You select from that drop-down box. I've got the little red box around. We're going to use Lua LaTeX because it supports TrueType fonts, which is something that we're going to want to do in a minute. So you compile by hitting the green button, and you get a page with fairly wide margins, like you might find in a journal article because we asked for the journal class. And there's a page number at the bottom, and our text appears in Computer Monitor. Okay, no big deal. Now, maybe you didn't like that page number. Um, so one thing that you can do in your preamble is you can tell it you want a different page style. In this case, I say I want my page to be empty. Okay. Um, and there's the result, right? Basically the same thing, identical to before, just no page number, just as we asked. Okay. Now, remember I said a minute ago that that document class was super important. Here's why. Um, here's another document class. It's called Beamer. Beamer is designed to make slides. So if we change the class of the document, we're telling the system, oh no, I'm not writing an article anymore. I'm making slides. So we're going to get exactly the same content, but the entire document is going to be set up differently because we've told it that we're making a different type of content. And here's the result. Now the page here is landscape, like your typical slide would be. The base font is now a sans serif font, which makes for easier to read slides. Beamer has no page numbers by default. And if you look at the bottom right-hand corner there, you'll see that there's some navigation buttons to help you move around the deck. So the upshot is that different document classes will render identical content differently depending on that specific purpose of the document. Makes sense, right? So you tell it, I'm doing a CV, it's going to do things special. You tell it I'm doing an article, it's going to do things different. You tell it I'm making slides, it's going to do some things different. Okay. So I'm returning back to the article class. We'll build out this document a little. First thing that I did is I added the LaTeX glyph. Just as an example of a symbol you could put in a document. You can put other symbols into documents, but most require external packages. There's one called Font Awesome that I recommend if you're interested in such things. We'll see that later. Second, you'll see that we've got that the dollar signs in there are in red thanks to syntax highlighting. The reason why they're red is because those dollar signs are special. They're putting us into and then out of math mode. Math mode is what you can use to set equations, and it comes in two flavors. If you use a single dollar sign, it will have the math equations print in line with the text. A double dollar sign puts you in display mode. The equation will appear in its own line, just like you'd see in a textbook or a journal article. Okay, so let's look at this equation that I did here. Y equals alpha. So I'm asking for a glyph here. That's why the syntax is highlighted, and I use that backslash. Alpha plus beta sub 1 x sub 1 plus beta sub 2 x sub 2. Then I asked for some plus, then some dots. Beta sub x, beta sub n x sub n plus epsilon. And that's how that renders. So it's a pretty easy way to typeset really nice looking equations. So LaTeX is really, really popular with scientists for that reason. Okay, build out just a little bit more. LaTeX is good with bulletized lists. You just put your list items in between itemized tasks, and there you get a bulletized list. Or if you'd rather have that list be numbered, you change the word itemize to enumerate, and now, instead of having bullets, the things are numbered. Okay. You can nest your lists, bulletized or enumerated. Here's an example of nested enumerated list. and you can see how that renders, much like you'd expect, right? So you make your list, and then you've got your, and then it indents and does all that nice stuff. Okay. LaTeX is also really good for long documents like books and dissertations because it helps keep track of the document structure. So here I've just added some section headings in between the various paragraphs. And now you can see that those sections, when I compile the document, those sections get numbered. If you use the book class instead of the article class, then you can also identify chapters, right? Article class doesn't have chapters because it's a shorter document. Okay. Also, if you ask for one, see there, I asked for a table of contents, and I asked for it to put the table of contents on its own page. So I asked for a page break after the table of contents. Um, it will create one right there for you. Because the table of contents is page one, all of those section heads are now on page two. Okay. You can also define subsections or even sub-subsections. And that's how those look. Again, these automatically number in the document and the table of contents really much as you'd expect. Now, I don't have time today to demonstrate everything worth knowing. We would probably have to be here for months. But I do want to note that LaTeX also does a great job with footnotes and endnotes. And there's a program called BibTeX that allows you to manage bibliographies. You define your sources in a database, and you tell LaTeX what reference style to use. Now, you can imagine if you've ever written a paper in, say, MLA format, only to find out that the journal you're submitting to uses Chicago style, you can imagine how useful it is to be able to just switch that with a few clicks. Um, BibTeX is in effect then a free replacement for commercial software like EndNote or Zotero. But if you already use EndNote or Zotero, you can use it with LaTeX. Okay, so now that we have a basic understanding of LaTeX, we can talk about how to leverage it to make some of those dreaded data fact sheets. Okay, so first step is to design a sample report. And by the way, I heard some of you saying that you had some old things lying around. You might, hopefully, you have some of the LaTeX code, and then you could probably reverse engineer the documents that you already have, and you wouldn't have to go through the design stage. But here we're gonna kind of design it. Okay, so we're starting with the basic article class. I asked for the page style to be empty, so there won't be any page number at the bottom of the page. And I'm going to call this demographic profile for Fulton County. Um, Once we get the design down for this whole thing, then we can write code that'll generate a whole batch of reports. Now note, by the way, that for each of these steps, if you want to sort of follow along later with the code, um, they're all called profile. So this is the first step. So this is profile 01. And then the next slide will be profile 02, and so on and so forth. And you'll find all of those profiles 01, 02, 03, and so on and so forth in that repository that I mentioned earlier. Okay, so that's how that renders. We were kind of expecting that based on what we saw before. Okay, maybe we'd like that title to be centered and maybe a little bit larger. So I'm going to use the center environment. I've got begin and end center. I probably should have stuck some arrows there, apologize. And then we've got some nested tag there to make a larger font. And also I want my text to be in boldface. It's a lot like HTML where you can nest your tags. One nice thing though about LaTeX as opposed to HTML is that since the end tag is always a right curly brace, you just have to count the right number of braces. You don't really have to worry about the order of the end tags, right? You know that in HTML, if you have the end tags in the wrong order, sometimes you get undesirable results. We don't have to worry about that here. Okay. And so there we've got exactly what I asked for. I've got my text centered, larger, and boldface. Okay. Probably want to add some content. Um, One common piece of content that we almost always have in our data fact sheets is some kind of table of data. There are a bunch of available table environments, but tabular is the simplest one and honestly will do the trick most of the time. So there's a begin tabular tag at the very beginning. There's an end tabular tag at the end. That's what my arrows are pointing to. Um, just like we had for the begin and end document. So we tell it we're starting a table, we're ending a table. And then the stuff in the middle, that is our columns of data. One thing that you have to do in LaTeX is you have to specify your columns. That's the stuff that comes in the curly braces after begin tabular. Remember, I said that what you can have a command, and then um, the required elements end up in curly braces. This is a great example of that. Here I want three. I'm going to have three columns in this table. Okay. Um, Two of my columns are going to be right justified, and they are going to size automatically based on the text. The fourth column, so you could use L, you can use R, you can use C. L for left justified, R for right justified, C for center justified. A fourth option is what's called paragraph.
Lucia, you're breaking up for me.
Oh, okay. Let me get closer to my mic. Is that better?
Oh, yes. No, I just got a note my internet connection is unstable. So it's just me, not you. Good.
Oh, okay. Okay. No worries. Um, I'll try to stay close to the microphone anyway. Um, so you may want to set the size of a column, especially if it contains long text, because then it will force it to wrap. And so that's what I did here. I used the P for paragraph, which is also left justified format. But in this case, I tell it that I want it to be 4 inches wide. So that column would be 4 inches wide regardless of the content. The other two will size automatically. Okay. So using that P justification requires you to set the width. So now we've got three columns in our table, one left justified 4 inches wide, the other two are right justified, size to the width of the text. And then there's always just a little bit of padding, unless you turn the padding off. If you need to set the width of a centered or right justified column, then you have to add employ some hacks, but we don't need that here. This white space that I have between the P and the R's, that's optional. I just included it to make it easier to read. Okay, so the next line is my table head. I have a blank, and then I've got count is going to be in bold, and then percent is going to be in the next cell, and that's also going to be in bold. And then the next rows are my data. So I have total population in the first column, I've got a number in the second column, 100% in the third column, and so on and so forth. Okay. That double backslash basically just gets you to the next table row. And finally, note that the percent sign is escaped so that LaTeX knows not to treat that as a comment. Okay, so that's what a table looks like, and that is how our table ends up rendering. And we can do lots of stuff with our tables. Maybe you like grid lines in your table. Not to my taste, but some people like them. Okay, so we define vertical lines when defining those columns. Okay, that pipe character that I stuck in there says where to put the vertical lines. And you can have more than one pipe if you want. You can have double or triple lines. Again, that white space isn't needed. I just did it to make it legible. Horizontal lines are added where desired with the H-line command. So I'm going to have lines all over the place here. That's how that renders. Not really to my taste, but some people like those lines. Okay, we're going to add some more content. So it would be helpful maybe to have some section headings before each item. Like, for example, I'll do race and ethnicity before the heading on this table, since it is a table of race and ethnicity. Notice that the section, earlier I showed you section and it got numbered, right? Now I'm using section with a star afterward. This is a special version of that command that will suppress the section numbering because I don't want it to say one race and ethnicity. I just want race and ethnicity. Okay. And so that's what we get there. And also I did educational attainment below. Okay. Um, so you may have noticed here that things look a little askew. This happens sometimes in LaTeX, and that's because I'm using the article class. The article class has very generous margins, and when the table, when a table definition and a margin come into conflict with each other, the table will poke into the margin, and that's what's happening here. So I'm going to fix the margins so that they'll be 1 inch all around instead of those wide article class margins that, like when you see a journal article, there's always like those wide, all those wide margins around. We want something that's not like that. Okay. And so to do that, we're going to have to use our first package. We're going to add a package to the preamble. In this case, it's called the geometry package. The geometry package allows you to have very fine control over your margins, um, binding offsets and all that sort of stuff. So you can tell it, if you're gonna, if this document is going to be bound, you can tell it to make, tell it to make the inner margin a little bit bigger for binding, all that kind of stuff. Okay, but we're just doing a basic 1 inch margin in our geometry package. Okay, and now you can see that that is much better. Okay, so we're going to add some more content. Okay, y'all can make fun of me for doing a pie chart because whatever, but I thought they're pretty, they look nice, they're easy to demonstrate, so we're going to do one for educational attainment. Now to do this, we're going to have to add, yep, another package to the preamble. There are actually a couple of packages you can use for pie charts. We're going to use wheel chart today. This package supports pie charts, donut graphs, and things like that. Now, the chart syntax is a little bit arcane because it's all built off of this vector graphic drawing program called LaTeX, which is also really arcane. Good news again is that you can take the code snippets that I've got for you. You can feed them to an LLM. You can ask it to explain the lines of code. You can get it to help you adjust them. But what you can see here is that we define some colors for the slices. We're using built-in colors for now. We tell it things like where to put labels and legends, the font size, the color to use, categories, proportions, all of that sort of stuff. The whole thing goes inside a TIX picture environment because Wheelchart is leveraging that graphic drawing package. Okay. And that is our chart. Okay. Okay, let's add another section to our fact sheet. Maybe you'd like to have a bar graph comparing cost burdened households by tenure. So you have owners versus renters, and maybe you want to do that for the county and compare that to the state as a whole. That's a pretty common sort of thing that you'd see in a that you'd see in a data profile, right? And so we'll need to add another package to facilitate creation of bar graphs, namely PGF plots. Okay. Again, this is super arcane because it is building on ticks. Most of the coding going on here is defining the axes. The bars themselves, you'll see those toward the bottom, there are those add plot lines of code. That's the main meat right there. So you're just telling it, I want a bar graph that's this, and I want a bar graph that's this. Okay. And that is how that would render. So I'm shaping up nicely, but I'm willing to bet that your organization, if it's anything like ours, has a style guide that you're expected to follow. Annoying, I know. We can instruct the LaTeX compiler to use custom colors and fonts. We just need, yeah, you guessed it, more packages. Okay, so the font spec package allows us to use true type fonts. Remember, I told you we'll need to use the Lua LaTeX compiler in order to use this package, which is why we've been using it all along. And so I'm I install that package and then I tell it I want DIN Pro, which is our one of our primary agency fonts. I tell it when I've got it installed on my computer, I say I want that. I want that to be the base font. And then we've got all these official colors for our agency. And so we use a package called Xcolor. And the Xcolor package allows me to define all the special ARC colors, like this official ARC red right there. By the way, RGB is not the only color space available to you. You can use hex values, like web design. Instead of RGB in that curly brace, you would put HTML. You can also use CMYK and a bunch of other color models in Xcolor. It's very, very flexible. And so now that I've just changed those couple lines of code and added I've more than a couple, but now I've added those two packages and defined what font I want and what colors. And I substituted the official ARC colors in the code. And now everything is compliant with ARC standards. Very good. Okay. Now that we have our colors defined, I can also pretty up the table a little bit. As I mentioned before, I don't really care for those lines, so I removed all those pipes. Instead, I'm going to use this row colors command, and that allows me to alternate gray and white rows in my table. And then also, I want to give the table a little bit more space to breathe. And so I told it, instead of doing single space, I want space and a quarter. Okay. And then I removed all of those. I removed, I also removed all of the horizontal lines. Okay. Um, you'll notice also after the end tabular that I reset the table row shading to default. The reason for that is because the pie charts legend is also a table, and I don't want to have that alternating shading. I don't want that to propagate to the legend in my pie chart. Okay. And that is how that renders. Um, so shaping up nicely. Maybe we'd like that demographic profile text to serve as a header at the top of every page. And what if we could have our agency logo printed at the bottom of every page? And maybe we could make that logo clickable so that if somebody is looking at a PDF on their computer, that they could click on it and have that open up a web page to our agency's website. Maybe the section headings could serve as bookmarks in the final PDF. These are all things that are nice to have, and they're all possible in LaTeX. We'll just need 4 more packages, one for each of those features that I mentioned. Okay. So the fancy header package allows us to define special headers and footers. The header will have the demographic profile heading in large indigo colored text. The footer will have our agency logo as a clickable link, courtesy of that href that I've got right over there. I want to suppress page numbers, which would appear in the bottom center by default, so I added an empty center footer. Then we've got the hyperref package. That's what allows hyperlinks. I've got the bookmark package, which shockingly allows for bookmarks. And then the graphic X package allows me to insert the ARC logo, which is stored outside. It's not, it's obviously not part of the LaTeX code. It's a PDF. I'm going to insert that logo as an image, and I'm going to also have it scale so that it's a 1/4 inch tall, regardless of what its base size was. I want it a 1/4 inch tall. Okay, so I've made those changes. We have headers and footers. If you were you to click on that ARC logo, it would in fact open our website in a browser. Maybe one last enhancement. I'd like to have those section headings match the header in terms of color. Okay. So we accomplished this by adding a text color command to the section heading. Below that, you'll see that this is optional. I added something called add contents line. That's because the starred version, remember we're using that starred version of the section header in order to suppress the section numbering. Unfortunately, it also suppresses bookmarks, and we want the bookmarks. So I'm going to specify the bookmark under the section header. Okay. And that's our sample fact sheet. Now we could continue to enhance this design, but then I wouldn't have any time to demo the good part, which is the automation. Now, in the original thing, I promised to show some applications using platforms other than Stata. So we're going to do an example in Python. Again, we're going to move quickly. Rest assured that the code we're going to look at is in the repository for you to inspect further. And also, you'll have time to look at it and make fun of my Python skills, which are not as good as my Stata skills. Okay. So, um, we're going to want to put geography-specific data into each of these reports. So the first step is going to be to assemble the data. Okay. Um, I've got some libraries that I'm importing. I'm importing pandas because we're going to use data frames. I'm importing requests because we're going to do API calls to the Census Bureau's API. And then the OS, because I need the OS module because later on I'm going to be invoking Lua LaTeX in order to compile our documents. Okay. Um, you can use this on your computer. You might need to change the file path to some place that you want it. I just said C data. And now the Census Bureau is requiring that you have an API key, even if you're just doing one request to their API. This is new this month, so you'll need to get one and you'll stick it right in that API key space. And then I'm grabbing the 4 tables that we need in order to assemble our data. I'm looping through those tables. Um, I'm bringing that all into a data frame. I'm merging those all into a single data frame. You also notice, and I have to do that because the Census API doesn't support a group call for more than one table, right? So you got to loop through, grabbing all 4 of those. You'll notice down at line 32, I have a shorter list of just 2 tables. That's because I only need the cost burden tables for the state, right? I don't need all the other tables. But it's the same basic process. Okay. So we've pulled in that initial bit of code is pulling in our data. After that, we need to calculate the actual data columns that we need within the data frame. For example, line 72 defines my percent high school graduate column. So it's the number of males who graduated high school and went no further, plus the number of females who did the same, divided by the total population ages 25 and over, which is that universe for table B15002. Um, so now we've got the data pulled from Census and all the required indicators are calculated. So for the next step, we loop through the rows of our county's data frame. We write the LaTeX code needed to generate each profile. So basically at this point, we're just programming a giant mail merge. Line 132 opens a file for writing using a file handle that I called it LaTeX file. The subsequent lines are just writing the contents of that LaTeX file we had designed line by line to this new file. Note that in lines like 143, we're taking advantage of the magic of F strings to write pieces of data unique to that particular county to the file. In the case there, we're writing the name. You might notice that I put that on its own line. And the reason I did that is because you may have noticed that LaTeX makes very, very heavy use of curly braces. Guess what else makes heavy use of curly braces? F strings. And so if you if you're writing very complicated LaTeX code, you end up having to double up all of your you have to end up doubling up all of these curly braces, and the whole thing just ends up being a complete illegible tag soup. So I just threw that on its own line. It doesn't have to be on its own line, it just makes it easier. Um, we've got the same deal going on in lines 182 through 187, where I'm writing those population counts and the percent for each race or ethnic group for the applicable counting. Remember, the F and F string stands for formatted, so we specify how we want those numbers to be formatted. I'm asking for the population counts to be formatted with commas separating the thousands, and for those percents, I have it rounded to 0 decimals. You can, of course, change this to taste. And then when we're done writing all of our code, line 273 closes the LaTeX document. Lines 275 through the end invoke the Lua LaTeX compiler to compile that code to a PDF. Then it does some cleanup by deleting these intermediate files that get created along the process. When you run Lua LaTeX, you'll see that there's in addition to the PDF, the original text file you had, and then the PDF file that gets generated, there'll often be files that end in .aux, .log, .out. Um, the log is a log file. The other ones are these helper files that help it sort of figure out stuff when it's doing all the calculations. You don't need once you're done, you don't need them, so I'm getting rid of them. And the end result is 159 PDF documents, one for each of Georgia's counties that follow the template that we designed, even including those bookmarks. And that is your basic flow. Oh, I see that there's some things in the chat. Does anybody have questions?
Oh no, just commentary that it looks like magic.
Oh, thank you. Okay. Oh. I'm trying to remember which I think it might have been Arthur C. Clarke who said that science fiction writer who said that any technology sufficiently advanced is indistinguishable from magic. So,
There we go.
okay. So, let me get back here. Right. Okay. So that is the end of the first unit. Um, if if you said, okay, this was great, but I gotta go, or this was great, but this isn't really for us, it was really interesting. This is a great place to drop off because in a second, I'm going to start that deeper dive. By the way, this first section ran a little bit long. The next two are shorter. We probably won't get done. We didn't get started quite on time, so we probably won't end quite at 1:30, but I will shoot for that. Oh, I have a raised hand. Yes.
Hi, thanks. This has been really helpful so far. I guess my question is, we do something similar, or I have done something similar in our Markdown for some of the work, and I was wondering if you could talk a little bit more about the difference. It seems like one of the benefits is that this works with Python and Stata in addition to R, but is there anything else you know about as far as like why someone would use this instead of doing something in R Markdown if your data is in R?
Um, Honestly, if your data are in R, I don't necessarily know that you would have a preference for using LaTeX. Um, so long as R Markdown does all the things that you actually need. Um, you can, you know, R, thanks to, you know, thanks to, the ggplot stuff, you've got great graphing. So you could use that to generate graphs. Um, I don't know if I haven't used R Markdown a lot, so I can't say uh, whether you'd be able to like import external graphics. Um, you probably aren't going to get uh, you probably aren't going to get the you know the LaTeX engine spends a lot of computation on trying to, figure out all of the kerning and ligatures and all that stuff. So the output might not be quite as aesthetically pleasing, but if your choice is between working in something that you already know and learning something new, I don't think that there'd be that much advantage. Um, you know, time, time is limited, right? Um, if our Markdown will do everything that you need, you should use it. But you might find, that maybe it's not as it may not be quite as sophisticated about how it lays out tables or things of that sort. But I'm sure you could get something more than acceptable out of our Markdown. It's a it's a pretty well thought out system. That was a lousy answer. I'm sorry.
Seems worth a Google or a Claude question.
Yeah, I mean, I think that you would probably be best suited designing the document that you want to use and then seeing if our Markdown will do it. And if it will, use it. I mean, if you're already familiar with it. That said, if you like LaTeX, there's no reason why you can't generate there's no reason why you can't generate LaTeX code in R. There are people who do that. Any of these, Stata, R, Python, they all allow you to write just raw text to a document, and that's basically all that LaTeX is it's a text with markup that you then compile into something else. So my best answer is try it and see. Was that an acceptable answer? Oh, I've got something in the chat. Is it
Oh, Kira just needed to drop off.
Oh, okay. No worries. Okay, any other questions before we move on? Okay, so we'll take a little deeper dive. If I can get this. There we go. Okay, so just quick review of a couple points. Remember, LaTeX is a markup language for typesetting. Our commands, command, options, required stuff. There's sometimes the starred versions, like the one that we encountered earlier. Preamble is required for the file. The only required piece of the preamble is the class of the document, but that's of course where we're putting the other attributes, like you could say who the author is, you can load packages, define commands, colors, and so on and so forth. And of course the document itself is between the begin and end tags. Okay. As I mentioned earlier, LaTeX uses certain characters for special purposes. You'll need to escape these with a backslash if you want the character itself, right? So if you want a curly brace, you have to do backslash curly brace. If you want an ampersand, you've got to do backslash ampersand. Because if you just do ampersand, it's going to say, what the heck? I'm not in the middle of a table. What's going on? You do a $ without that slash, it's going to put you in math mode, and you're not going to get the desired result. The one exception is the backslash itself. A double backslash means a carriage return. So double backslash isn't going to get you where you need to be. There's a special glyph, text backslash, that'll give you a backslash. Okay. Returning to the preamble, the document class, again, is a required element. And it determines the base layout of the document. Font, base font size, so on and so forth. Here are some useful ones. I'm not going to go through them all. You can look at those slides later. But article is a good default. There is a slides document class, but almost everybody prefers Beamer. Some of the options you can set are things like the base typeface size, paper size, the paper orientation, things like that. Those are some of those options that go in that document class. One side versus two side matters if you're creating a document that's going to be bound. Okay. Page numbering lets you decide what types of numbers. Page style lets you change the headers and footers, but the fancy header package lets you have a lot more control over the headers and footers, so most people use it. You can also embed things like the title and author in the preamble and have those items appear on title pages and so on and so forth. And then there are the packages. It's a very long list. I'm not going to go through it right now, but I've got a list of some of the very useful ones and what each one does. For example, I mentioned Font Awesome earlier. Font Awesome lets you include special symbols in your document. So if you have the Font Awesome package installed and you want to have the rebel icon, then you just do \FA rebel and it will print in that spot. Okay. A couple of the packages that are really must-haves, besides the ones that we've already looked at. T-color box is really, really useful. It's responsible for the green box, the blue box, and all of those colored bars marking each section in our data profiles. That's one that is a must learn. The graphic package we actually saw earlier, it allows me to include the ARC logo and also the inset maps. Those exist as external files. I'm not writing that. I'm not creating those in TIX. Those get created externally and they get inserted into the document. And the EndNote package allows me to have endnotes with all my data sources, which we'll see how that operates in a little bit. We've got some R users here. So you're familiar with CRAN, right? The comprehensive R archive network. Python users use PyPy, which is the Python package index. Similarly, LaTeX has CTAN, the Comprehensive Text Archive Network. There's over 6,600 packages, all kinds of stuff available. There are even packages for typesetting chessboards, packages for typesetting musical scores, you name it. It almost seems like somebody's thought of it at this point. If you need special symbols, they've got you covered with a comprehensive list of how to get those. I talked about sectioning a bit earlier, but just for your reference, here's a list of the various levels. Now, of course, remember, not all levels exist for all document types. For example, you know, chapters don't exist for articles. And just to sort of understand a little bit better the mechanics of how LaTeX works, it works best when you tell it, when you have your, they call it what you see is what you mean system rather than what you see is what you get system. You tell it what you tell it a base font, and then you tell it I want things that are larger, or I want something that's huge, and it will automatically pick a font size relative to that base size. Text styles, you've got Roman, slanted, italic, boldface, small caps, typewriter, sans serif. You can, of course, mix these styles. Okay. Environments, I've mentioned them before, but here's a little bit more formal definition. Again, LaTeX, what it really wants you to do is to give it the content and you tell it what the content is, what class that content belongs to, and then it will typeset it based on what you've told it, what type of content. And so here's a list of some popular environments, again, for your reference. Here's how some of these play out. For example, a description environment has items and then a corresponding description. So you get your item, Bilbo Baggins, and then you've got his description, a hobbit who goes on an unexpected adventure, and so on and so forth. And here's how that description environment lays things out. lays out those pairs. You can change the justification of your text through environments. So you can tell it, you want things flush left, flush right, you want things centered. You can tell things, you want things ragged. And here is how these various things come out. If you have a block quote, you put it in a quote environment, and it will set your quotes. If you have poems, you put it in the verse environment, and it sets it. And so basically, you would tell it. You would tell it. Let's say that you were doing a book with lots of poetry. You would put each poem inside those verse environments, and then you would, somewhere in your preamble or the beginning of your document, you would tell it what treatment, if you're not happy with this treatment of verse, you would tell it what treatment all of the verse should have. So you can basically modify that, how that environment behaves. And then if you change it up top, then it will cascade to all of the times that you invoke that document. Kind of like CSS works with web pages, right? Lengths are all related to spacing. The general format is you set length, and then inside one set of curly brackets, you give the name of the thing that's getting set. So that could be how much indentation you're using, how much spacing between lines and paragraph, spacing between paragraphs, any of those things. And then you give it an amount. Okay? And amounts can be specified in lots of different units. You can do it in terms of points, picas, imperial units, metric units, even typeface dependent units. So you can operate in terms of inches or points or millimeters or centimeters. It doesn't matter. Whatever works best for you. Okay. You can also add some, if you don't like how things get laid out exactly, you can always add a little vertical or horizontal space with these various commands. And one of the commands worth mentioning, we've got these hfill, stretch to fill a line, hrule fill, and hdot fill. So I've got a sample code just so you can sort of see how each of those behaves. Right. So flush left. So so just hfill gives you blank space. Hrule fill gives you a line between them, and dot fill gives you dots. Last thing I'll mention is footnotes and endnotes. Footnotes are built into LaTeX, while endnotes require adding the endnotes package to your preamble. They basically operate the same, except that footnotes, of course, appear at the bottom of the page, and endnotes appear at the end of the document. Or actually, they appear where you tell it to put it. In both cases, and this is a little weird, in both cases, you stick the text inside a footnote or endnote environment at the spot where you want that superscripted number to appear. Yeah, I know that sounds weird, but think about it. That's how all of the environments work, right? You say an environment, you put something inside an environment, and then it decides how it's going to handle it, right? So you're putting that footnote text right by the spot where you want that footnote to happen. And so here's how that code that we had there renders. Okay. Okay, so that was a little bit more. We went through that pretty quickly, but just dig a little bit, just one level deeper into some of the mechanics. Because if you're going to actually be writing your own LaTeX code, then understanding some of those concepts will be really helpful. I learned the hard way, which was I didn't know any of this stuff. I was just looking at code snippets other people had written. I didn't always understand why I was doing what I was doing, and then things would break, and so a little bit of background is sometimes helpful. So we're going to switch over to the third unit. And so if you're not interested in this data specific tool, again, this is a good time to good time to say your goodbyes. That said, I will talk a little bit about how it works in case you decide that you do want to build something in a different platform, but it's really going to be mostly Stata focused. Before I move on to the next thing, are there any other questions or thoughts? Oh, I've got something in the chat. Yeah. Let me see. Oh, okay. Okay, got some people leaving. No worries. Okay. So we will move on. Uh-oh. Need to hide that. Let's see. Okay. Okay. So I'm going to talk about LaTeX. Why did I write this thing? So the original story, um, I designed these data profiles a very, very long time ago. And every once in a while, we needed to change formatting, rebrand, change what was going into a table. And it was really, really a huge pain. And in particular, Neighborhood Nexus 1 year, uh, Tommy got somebody on his board who knew a lot about branding, and they decided that they were going to change all of the official colors and styles and all that kind of stuff, which made everything a lot nicer. But the way that I had everything coded, it meant a lot of work on my end. And then the following year, Neighborhood Nexus spun off as its own organization, which is why I'm now an alumnus. And we rebranded everything. We were going to rebrand everything ARC. And I said, okay, if I'm going to have to keep rebranding this, I really need to, and we're going to keep messing with the tables, messing with all this stuff. I need to come up with a better system for doing this. And the thing is that when you're doing these tables, you've got to format different numbers differently, right? You got your dollar sign, you got your dollars, you got percentages. Sometimes you want your thousands separated by commas, sometimes you don't. Sometimes you want things rounded to different decimal places. Um, there's a lot of stuff going on uh, in these tables and getting everything formatted the way you want it. And I wanted a system that was going to allow me to do this a lot faster. And so my solution to this problem, because it used to be that I'd have like tons of code, basically hard coded each of these tables, was to create a table of tables, and then to write a program that looks at the table information, applies the necessary formatting to all of my numbers, places the code around those numbers to define the table. And that means that if I need to create a new table, I don't have to spend a whole bunch of time programming. I just go into an Excel file or a Stata document, and I type out these specs, which we'll see in a minute, and then I can then invoke that table from Stata, and I'm in business, and it cuts the time of generating a new table down by a significant amount. One thing about LaTable, it requires Stata 16 or higher, and the reason for that is that you have to have 2 data frames in memory. Prior versions, 15 and earlier, only allowed you to have 1 data frame in memory at a time. But I need to have the table definitions in 1 frame and the data that we're going to put in another frame, right? I need them both simultaneously. Fortunately, Stata 16 came out in June of 2019, so probably most people have 16 or higher at this point. We're now on Stata 19, which came out not that long ago. So, okay, so what kind of information goes into this table of tables, you wonder? Well, each row of definitions corresponds with 1 row of that actual table. And each row of the table is going to be one of a few different types. It could be a table title. It could be a header row. So a header row would be like, where we put, so the table title would be where you say something like, race and ethnicity, right? The header row would be where you'd have things like, count or percent. data rows are sort of self-explanatory. That's where the actual data get reported. And then I also have the opportunity to create blank rows if you want to have a little space in between particular spots. And then for each thing, we need to tell it. We tell it what category of table. We tell it that we give each table a name. That's how the table gets invoked. There's indentation. And the reason for indentation is because in a lot of tables, you'll have sort of that hierarchy where you'll have like, you know, you'll have something and then of which, right? And that of which needs to be indented, right? So we've got some indentation. We need to tell it what text is going to be in that row, like, uh, you know, total population, uh, non-Hispanic white, non-Hispanic black or African American, those kinds of things would be text in that column one text. Then I've allowed for up to 4 data columns. And so that would be the variable name for those things. Or if it's a header row, you have the text for the headers. Sometimes you're doing change measures and you want to have a significance flag. And so there's a variable which would just be kind of you might have a star or a dagger or something, right? To have significance. So you put that there. And then each piece of data, we need to let it know, what data type it is. Is it a number? If it's a number, then we're going to do that. We're going to separate the thousands. If it's a percent, we're going to stick the percent sign after. If it's a margin of error, we're going to put that plus minus on it. If it's a percent margin of error, we're going to put plus minus and a percent sign. D1 means we're going to round it to 1 decimal, D2 to 2 decimals. You see where this goes, right? And then if you want to have a footnote, that would go in that notes field. Okay, so this is the basic information that needs to go into a table. Let's sort of see how it works in practice, and then we're going to do a real new example. So this is a sample table from the ARC data profiles. It seems simple enough when you look at the table, but there's actually a ton going on. Every table needs a title, and you probably want to let the reader know the vintage of your data. You probably want to have a footnote or endnote or something with the data source. You want your column headers to be clearly marked so you can tell them apart from other things. You're going to want some kind of total row in order to let people know that the total number of cases that all these percents are based on. And then we've got this indentation. I got something in the chat. Does somebody have a question? Oh, gotta go. Okay. And so this is what that definition looks like. Here's what the table specs look like for that particular table. So we got the title row. The content of the notes over there is what's going to appear in my endnote. So we've got I have my data source right there. I've got the header rows. Those are the column headings that appear in bold. You notice that I put carriage return, so I want margin and of error to appear on different lines. Then I've got, in these other things, I've got my data and I've got type, right? So I want my total population is going to be, my variable is called totpop underscore E. My margin of error is totpop underscore M. And that formatting in type 3 number is going to get applied to data 3, and type 4, my margin of error where I'm going to want that plus minus, is going to get applied to data 4. It's pretty simple. Okay, and then if you've got that all set up the way you want it, creating a table is just invoking one line of code. You say LaTeX using, that's the path to that table templates file we we're just looking at. The name in the template file, I'll flip back there, you see it's called place birth 2, right? Row colors, that's an optional option, so you can interleave colors or not. It needs to know which observation as we're looping through the records. And this is again optional. Do you want to add that you want to add the data's dates to the table title. If you do, then whatever comes in print date is going to have a comma and then that stuff thrown into the title. That's the code that it generates, which, as you can imagine, is a pain to write by hand, but we don't have to do it by hand anymore because we've got a nice little application that does it for us. And that's what comes out the other end. Okay. Are the Data Haven folks here? There was somebody signed up from Data Haven. Maybe not. Okay. Um, I thought it'd be nice to do an applied example. I looked who was registered for the webinar and I poked around on your various websites and I struck pay dirt with Data Haven because they had a nice interactive visualization of city neighborhood profiles, but they didn't have any static profiles, at least not that I could find. And they also had a CSV file with the neighborhood profile data. So there's some nice raw materials. They also mentioned in their thing where you could get some maps for their neighborhood boundaries, which was also useful. And they had some documents that I could harvest some of their colors from. So I looked at the CSV that was available for download, and it had about 50 indicators covering about 6 basic topics. So I basically just built a specs file to cover all these indicators. By the way, this whole package is again in the repository. If you want to inspect and use, you can see the input CSV. You can see this file that I created. You can see the code that is going to generate profiles. All that stuff is there for you. Harvested some colors from a recent publication, found a logo online. City of New Haven has a feature service of their neighborhoods on their open data portal, which allowed me to export a shapefile, and then I generated inset maps for each of their 19 neighborhoods using 2 of those colors. I wrote a do file to prep the CSV data. Most of that is just renaming things to renaming variables so that it would be easier to work with. I grabbed some text from their website about the organization, and then I wrote a do file to generate and compile the LaTeX code for each neighborhood. Again, this code is in the repository, but if you look at the first block, I'm basically writing a preamble that uses the packages we'll need. We need the table package. I'm sorry, we need the XColor package to do to define our colors. Hyphenate package, I've turned off hyphenations. We want to enable true type fonts. We want to use endnotes. We want to have the hyperref in order to have the clickable links, all that kind of stuff. I've got comments there you can see that explain what each of those packages I asked for are. Then I defined their colors based on what I harvested. And then we've got the data profile itself where I've got first thing is we have some boxes that have their special colors and that text that I harvested. And then we have then we invoke the lines of code to generate the tables. And this is the output. Start to finish, it took me about 2 hours to do this because
we'll share the recording with them.
I'm not saying that they should use this or that they need this. It was just, hey, all the elements were there. Let me do this right quick.
Well, it's a good
just to
testament
show
to
you
their open data. They're publishing everything.
Right. So I just wanted to show how easy it is by doing an applied example. And so they drew the short straw. And that is basically that. Look at that. It is 1:30. We are right on time. I just want to remind you one more time that everything here, this deck, all the code samples, the table, a do file, an accompanying help file, though the help file is not very good, I'll admit, because I wrote it for an audience of one, that being me. Um, and then that sample project for Data Haven with all the code, all of that is in the repository. So I will stop sharing. I will turn my camera back on, and I will take any questions that remain from anybody who was masochistic enough to stick around for the whole hour and a half.
I thought that it was quite easy to stick around for the whole hour and a half.
Okay.
We don't use Stata much. We're really in R and Python here, but
Mhm.
it was interesting to kind of see what you were able to put together and think through like if it's worth us trying to build out something similar to kind
So
of
my
augment.
R game is weak, but 100% you could do this in Python.
Yeah.
You
Yeah, I
could probably
think
do it in R too. That's just my R game is weak, so
yeah,
I can't.
mostly probably depend for us on who it was taking on the task of doing it. I'm a lot stronger in R, but some of our other analysts are better in Python. But I think the team is going to be interested in this one, and we've been using it. I use something similar in R Markdown for um reporting survey results like a while ago, just because we had this like statewide survey we were doing and kept needing municipal outputs of those that the project team wanted to see like every month how the results changed. And I didn't want to make a new Excel chart every single month based on the same survey. Um, and save
No,
myself a lot of
100%.
time with it. But yeah, it does like kind of to my earlier question seem like really the difference is that the LaTeX looks nicer than what you could pull off in our Markdown without it.
It also
Um,
gives you a little bit more. I'm going to pull something now that I've gotten through everything. You keep talking. I'm just going to pull up another document.
yeah, that was like I was kind of Googling around in the background too. And that seems to be the
It's
um
pretty.
it's just it looks nicer, but knowing that like it seems like I can kind of use the LaTeX within an R Markdown
Yeah.
document even to like because yeah, like R Markdown seems like it'd be better with ggplot, like you said, for the charts especially. Um, but to be able to kind of integrate the LaTeX into it and get an output that looks nicer, I could see us doing that. Yeah, mostly I just didn't know what was possible. This was a very helpful, like, here's everything it could do if you wanted to learn how to use it. And I do think it'll be worth it.
So I'm going to
And I
show
think
you.
too,
Oh,
judgment about those are good questions. Like sometimes pretty might matter and sometimes pretty doesn't matter. If it's like to an internal working group once a month, then maybe it's not worth the time.
Exactly.
It's like for, a funder final deliverable that they care about a lot, maybe it's worth the time. So that's interesting.
Yeah, and knowing that you can integrate it with Zotero was also helpful because I think there's a few things where like I know we don't do a ton of publication here, but there are a few things we've been thinking about trying to move in that direction with. And I'm most familiar with Zotero and have been using that to save all my citations. So being able to merge those will make a difference and let me make something nicer than a Word document, but not have to manually do the citations. So
now I've never done it myself, but I do know it's possible because I'm not a Zotero user.